Hi everyone. In this video we are going to discuss about a resonance effect or mesomeric effect. So basically in this kind of effect what is happening, that is basically the presence of some groups that will be introducing either resonance or mesomerism in some molecules. So what will be the after effect of the presence of these group? It will be generation of some centers, which that centers can be of high electron density or low electron density by the delocalization of pi electrons or non-bonding electron. What is the cause it will be producing? So such an electron displacement effect caused by the phenomenon of resonance or mesomerism in a molecule is called resonance effect or mesomeric effect. So now we will focus mainly on minus R or minus M effect and plus R or plus M effect. So depending upon the nature of the group which is present adjacent to the multiple bond in the molecule, there can be resonance effect or mesomeric effect, which are of two types, which I discussed earlier, like minus R minus M or plus R plus M. So here we are going to discuss about minus R or minus M effect. So there will be some groups which are particular in causing this kind of minus R effect or minus M effect. So some groups like C double bond O, then another group which is causing minus R or minus M is NO2, the another group is C triple bond N, then another is COOH, the acid group, then COOR, the ester group, then SO3H. So these are examples of groups which are able to produce our minus R or minus M effect. So basically what is happening when these kind of groups are present adjacent to multiple bond, that means double bond or triple bond in a molecule, and that bond should be in conjugation with that means it should have alternate single bond, double bond, something like that. So then there will be a chance for resonance or mesomerism coming into play by withdrawing the pi electrons of the multiple bond. So basically if these kind of groups are present in a molecule, so what will these group will be doing is, these group will be taking out the electrons from the molecule. If initially the electron density will be high, by the coming of these groups what will happen is the electron density will be lowering, because these will be withdrawing the pi electrons of the multiple bond, thereby causing the electron displacement towards these groups. Suppose if imagine in this kind of benzene system, if any of these functional groups are present, so what will it do is, these are the pi electron densities of the benzene molecule. So if these groups are present, these groups will be withdrawing the pi electrons. Pi electrons mean these three things. So pi electrons will be withdrawn from this molecule towards this side, thereby causing electron displacement. So electron displacement will be happening. The effect produced by these are called minus R or minus M effect. So I'll show one example. In this case, suppose we'll take vinyl cyanide molecule, CH2 double bond CH single bond C triple bond N. So these here N is having a lone pair of electrons. So see now here the cyanide group is there, and in this molecule CH2 it will be, so one hydrogen will be replaced by our cyanide group. So what will this group will be doing is, all these groups have the capacity to withdraw electrons towards these groups. So here the cyanide group, here the triple bond will be taken towards the nitrogen side, so carbon has to fulfill its valency. So that is done by taking the electron density from this bond. So this will be existing like CH2 CH double bond C double bond N, it will be having 2 more lone pairs. So basically negative charge will be coming and here a positive charge will be coming. So this is an example of minus R or minus M effect. So this is basically minus M effect. Now when a group showing minus effect is present as a substituent on the benzene ring. So basically, so this here we discussed about minus M effect. So coming on to minus R effect, the same group, if it is present on these benzene ring system or circular system, cyclic system, it makes the benzene ring less reactive towards aromatic electrophilic substitution reaction. So when it is taking up all the electron density, so it will be less active towards a electrophilic substitution reaction. So such groups are called deactivating groups. So these same itself when present in benzene ring, these are called deactivating groups because these groups are basically reducing the activity of benzene towards electrophilic substitution reaction. So for example, if consider the example of NO2. NO2 is considered to be a strongly deactivating substituent. So if NO2 is present on our benzene ring, so what will happen is the NO2 is a strongly deactivating group. So it causes the delocalization of the pi electron density of the aromatic ring on towards this group. So basically the electron density, pi electron density of the benzene ring will be taken by the NO2 group, and thus the delocalization of everything will be happening and the benzene ring will be less active, and it is basically due to the minus R activity of NO2 group. So if I am drawing the resonance structures of nitrobenzene, it will be like this. Here oxygen will be having 6 electron pairs and negative charge. Then comes our benzene ring. So here NO2 group is nitrogen. Here it will be having 2 lone pairs. Here what will happen is this bond will be shifting towards nitrogen. So to cope up with the valency and all, here this bond will be shifted to this side. So this will be our first structure. The second structure, here it will nitrogen will be there. Nitrogen will be having a double bond because this bond is shifting to this side. So it will be having a double bond. Then here a positive charge will be coming because here when this bond is shifting, this valency it is okay, but here a positive charge will be coming. And here oxygen, which is having 6 lone pair and minus, here as usual the 6 lone pair and a negative charge will be coming, and this will be the second resonating structure. And here what will happen is this negative charge will be transferred to this position. So it will be like nitrogen, it will be having, here also nitrogen will be having a positive charge, nitrogen will be having a positive charge, oxygen, then as usual the 6 lone pair on whole electrons, and the structure will be transferred like this. So here what is happening, this double bond is getting shifted to this region, and here the plus sign will be there, and this bond will be getting shifted to this position, and this will be the third resonating structure. And here I am drawing the fourth resonating structure. The fourth resonating structure, nitrogen will be having a positive charge. Then here it will be in this position, this will be the bond, and here then it will be having positive charge here. Then oxygen with 6 lone pair, negative charge. Then this bond will be getting shifted to here, this position. That means here a bond will be coming. So that will be our last resonating structure. It will be like here. So lone pair will be, here it will be 6, here it will be 6, here it will be 6. So this will be coming usually like normal to our first resonating structure. So our first resonating structure and the fifth one will be the same. Negative charge with 6 lone pair. So this will be the last resonating structure. So basically what is happening is in minus R or in minus M effect, so presence of these groups, because of these groups are present on a molecule, what will happen is this group have the tendency to take away electrons towards its side, towards the functional group the electrons will be moving. So there will be vacancy of electrons, or electrons will be lesser in the actual molecule where it was present. So, and it is basically by the shifting of or a delocalization of pi electron towards these group. It is a speciality of these groups. So and basically that will be happening in multiple bonded systems. So resonance or mesomerism come into play by withdrawal of these pi electrons of the multiple bond, and thereby causing electron displacement towards our functional groups. So this is our minus R or minus M effect. Thank you.